I'm here. I made it. It's Tuesday. It's Tuesday. We got sugar-free Red Bull. Excited for that. We got typing tests to do. Not excited for that. Yeah, I'm like, I don't really know what to say. We gotta just go and do it every time. I don't really know how to, what's the word? Riff? I'm like, is that the word? Okay. I have to go do the Engine Explorer. All right. Now, last time I had Minmo, yeah, riff it. Yeah, last time I had Minmo, so I was like looking at my keyboard. I'll try not to, but I might look down. It did help. Okay, am I clicked in? Making sure we're good? Okay. Because once I go, I have to go. You know, we're going. I just feel like it helps. Why can't? Because you need to be looking at the screen. Like, why can't I? If you're looking at the screen, you could be more productive. Honestly, I'm a little bit just like, can I just get my muscle memory right first? Where my hands are supposed to go, my fingers are supposed to go. Shit. See, because when I look, I actually start not keeping my hands on the home rows because I'm just like going to the letter. That was kind of quick. Shit. Shit. No. See, we also need to do tests where I don't erase. See what our accuracy actually is at. Q short. Key plugin. No. No. Damn it. Oh, yep, that was space. M engines on. No. Okay. Oh, music's scaring me a little. Current index -1. Done. That's not bad. That's kind of cute. I was like kind of sort of cheating. But that's how bad we are even while cheating. Excellent. Very nice.
Very nice.
Okay, we are doing characters. Characters Day 4.11 chars. To this point, the fundamental data types we've looked at have been used to hold numbers, integers and floating points, or true or false values, or booleans. But what if we want to store letters or punctuation? Okay. Would you like a burrito? Yes or no? We want the user to enter Y or N character. How do we do this? Character input. If Y, then that's probably not how it would work. The character data type was designed to hold a single character. A character can be a single letter, number, symbol, or white space. Oh my god. Where is burrito? Character can be a single... I need to turn this down. I don't know if it's too loud for you guys. Let me know. Character can be a single letter, number, symbol, or white space. Character data type is an integral type, meaning the underlying value is stored as an integer. Similar to how a Boolean value 0 is interpreted as false and non-zero is interpreted as true, the integers stored by a character variable are interpreted as an ASCII character. ASCII stands for American Standard Code for Information Interchange. It defines a particular way to represent English characters. You right? Okay. Let's do... We'll turn this to that. And hang on. Actually, let's do more like that. And then I'll put this up. How's that? Well, actually maybe up a little more. That feels crazy. Okay.
Testing, testing, testing.
Wee woo.
Wee woo.
Wee woo. Is that better? Too loud? Is it too much? It is better. And then how is trying to think of one to test with. That's probably a good one.
That's Danny.
Because this one's kind of loud. I don't know. Anyways, should be fine. Okay. ASCII stands for American Standard Code for Information Interchange, and it defines a particular way to represent English characters, plus a few other symbols, as numbers between 0 and 127, called an ASCII code or code point. For example, ASCII code 97 is interpreted as the character A. I feel like I've maybe... hi, by the way. I feel like I've maybe read that somewhere. That, like, you know, C++ kind of just adds some, like, building blocks to C. I guess I kind of felt like I had learned Java, and so I know slightly, like, the basics of programming already. So I'm like, I need to learn C++. So let's just go into it. And this website, this tutorial, it really is very, like, base level. At least so far. I feel like they're going over every subject, like, in great detail. So there's enough time, like, spent on it, and my mind can, like, adjust before we move on. I don't know. We haven't had too much of a difficulty yet, but we're not very far. So I know we're going to get to the point where I'm like, what? I don't understand. Um, Thank you for the good luck, the well wishes. Yeah, I mean, honestly, I'm wanting to at some point, obviously not soon, but like develop my own video game engine. And so it just kind of felt that C++ was the direction to go for that, or something like that. Like I'm not super like loyal to a language or anything. It's just like from what I when like researching it, everyone complained about C++, but always, you know, say it's like they have the comment of like, well, it's really powerful, it's just really difficult. So then I'm like, well, then I want the power. Give me the power. I'll do it. I'm not afraid of the challenge, I guess. I don't know. Character literals are always placed between single quotes, like G and 1. Here is a full table of ASCII characters. That's crazy. Thank you, though. Delete. Codes 0 to 31 and 127 are called the unprintable characters. These codes were designed to control peripheral devices such as printers by instructing the printer how to move the print head. Oh my gosh. What? Most of these are obsolete now. If you try to print these characters, the results are dependent upon your OS. You may get some emoji-like characters. What? That is crazy. Hang on. End of transmission. Inquiry. Acknowledge. Bell. Backspace. Yeah, like carriage return. That sounds like typewriter shit. Like, shift out, shift in. Data control. Data link escape. Negative acknowledge. Synchronous idle. End of transmission block. Cancel. End of medium. Substitute. Escape. Unit separator, record separator, group separator, file separator. That's all for freaking printers? That is crazy. Wait. Peripheral devices such as printers. There could be other stuff. That's so interesting. Acknowledged. Wow. Okay. Codes 32 to 126 are called printable characters, and they represent the letters, number characters, and punctuation that most computers use to display English text. If you try and print a character whose value is outside the range of ASCII, the results are also dependent upon your OS. I was like, I feel that there is more than 127. I think that is like the more emojis and stuff. I've still worked with new modern printers that work by ASCII commands. It's not completely obsolete. That's so interesting. Like, that's kind of like, I'm like looking at this, like, this feels like these could still be used for programs and things, like acknowledged and end of transmission, stuff like that. That is so interesting. I assume it's like for like the dot matrix printers and things like that is what they're like talking about mostly, or it's like newer printers are still needing it. Is that? I don't know, that's so interesting. Initializing characters. You can initialize character variables using character literals. Right. Which that's like what we have been doing. We just, I guess, it's just been under like character output. we've not been storing data as words. We've just been outputting words. I think that's okay. Barcode printers, yeah. Also, I feel like like the really simple like card readers maybe, or like they just get like the keyboard, like the number from the credit card, probably like stuff like that. Barcode reader, that's so interesting. Initialize with A, and it'll store it like in the CPU as 97. Okay. You can initialize characters with integers as well, but this should be avoided if possible. Oh, so you could do the ASCII, but it would be confusing to read, I bet. Because I don't just know ASCII off the top of my head. Be careful not to mix up the character numbers with integer numbers. The following two initializations are not the same. Gotcha. Character numbers are intended to be used when we want to represent numbers as text rather than numbers to apply mathematical operations to. Printing characters. When using standard character output to print a character, standard character output outputs the character variable as an ASCII character. Oh, when you just ask it to output this, it's going to output the number. Oh, AB. Wait, what? Oh, okay. No. Wait. Oh, as an ASCII character, I thought I'm like reading it as it's saying like it'll output the ASCII number. I'm like, what? What? Okay. I'm like, I don't see it. We can also output character literals directly. You don't have to initialize it. You can just output it. Okay. This produces the result C. Inputting characters. The following program asks the user to input a character, then prints out the character. Okay. Initialized. Okay. Here's the output from one run. Q. You entered Q. Note that character input will let you enter multiple characters. However, variable CH can only hold one character. Consequently, only the first input character is extracted into variable CH. The rest of the user input is left in the input buffer. Oh, that's not going to be good. That character input uses and can be extracted with subsequent calls to character input. Okay, so we could have in the code to pull, like if we asked them to put in 5 letters, we could pull still one letter, but 5 times. It'll pull it from the bus. Okay. We just want to do that. Do it like that. A, B, C, D. You entered A. You entered B. Okay. Note, the following character input doesn't ask the user for input. It grabs queued input. Interesting. Yeah, so we could like do this 5 times. And it'll do, or 4 times. It'll do A, B, C, D. If you want to read in more than one character at a time, to read in a name, word, or sentence, you'll want to use a string instead of character, right? A string is a collection of sequential characters, and thus a string can hold multiple symbols. We'll discuss this in upcoming lesson 5.7, Introduction to String. Extracting white space characters. Because extracting input ignores leading white space, this can lead to unexpected results when trying to extract white space characters to a character variable. Assume that user enters A/B without quotes, extracts A, leaves B in stream, skips leading white space. Okay. That. Extracts B, leaves new line in the stream. Oh. So new line. Wait, what? Leaves B new line, takes the B, and then there's just new line as a character. That's interesting. A entered B. In the above example, we may have expected to extract the space, but because the leading white space is skipped, we extracted the B character instead. One simple way to address this is to use the character input get function to perform the extraction instead, as this function does not ignore leading white space. Interesting. We need to get what is inputted. Like, we have a character input, but you really need to get that input. Oh, interesting. Does not ignore white space. A, B, and then you just get A, and then it just like dropped it. They might need to explain that a little more. Extracts A, leaves B new line in stream, extracts space. Oh, okay. So the next one was space. So if we did it again, then it would be B. And if we did it again, then it would be new line. That's what happened. Okay. This one is just space. Interesting. Okay. I get it now. I see now there's space there and not there. Okay, we're on it. We're going. Character size, range, and default sign. Character is defined by C++ to always be 1 byte in size. By default, a character may be signed or unsigned, though it's usually signed. If you're using characters to hold ASCII characters, you don't need to specify a sign, since both signed and unsigned characters can hold values between 0 and 127. If you're using a character to hold small integers, something you should not do unless you're explicitly optimizing for space, you should always specify whether it's signed or unsigned. Signed character can hold a number between -128 and 127. An unsigned character can hold a number between 0 and 255. Escape sequences. There are some sequences of characters in C++ that have special meaning. These characters are called escape sequences. An escape sequence starts with a backslash character and then a following letter or number. Gotcha. We've already seen the most common escape sequence, which is new line, which can be used to print a new line. Okay. Can be embedded in double quotes because we've escaped. This outputs first line, second line. Okay. Value of x is 5. Another commonly used escape sequence is \t, which embeds a horizontal tab. Oh. Okay. First part, second part. We've escaped here. Wow. I have wondered how to do a tab. That's crazy. Okay. 3 other notable escape sequences are \apostrophe, or is that right? \quotes prints a double quote. Oh, single quote, that's what it is. I'm like apostrophe. And then double \, prints a \. Okay. Here's a table of all the escape sequences. What? Sorry, it makes an alert such as a beep. I want an alert. Just beep at me. Like if I put \A in my code, what is going to beep? Anything that is programmed to accept that. Backspace moves the cursor back 1 space. Okay. Next logical page, new line. Yeah, I'm thinking like that's probably what it is, right? Like the motherboard speaker would be where it would come out from. Like, that is so cool. I'm just like, write something that just makes it go off. Like, beep, 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 beep. Carriage return. So that's the typewriter. I'm like typewriter stuff. Move cursor to the beginning of line. Horizontal tab, vertical tab. Interesting. Single quote, double quote, backslash, question mark. Translates into character represented by octal and hex number. I don't know what an octal number is. Is that like, I feel like error codes when it's like 0x something something. What the hell is that? Jesus. Octal code? Just want to look at it. Why does none of this look like familiar? Like hex is so familiar just because of colors and shit. But I'm like, okay, octal code. Like, what do I use? What do I do in work that relates to this? Octal value. I don't know. I'll have to learn more about it. Seems like it's... They just keep showing a lot of binary stuff. Oh! Base 8, so base 10. Base 10, 9, octal is 11. Yeah, I'm just like trying to think like driver, like hardware IDs, or like what am I thinking of that it uses that? Old early computing stuff still exists in modern C++. And I think that's what I like about it, is that like it's still very strong for like, or the language is still very strong for like modern things and has that like backwards compatibility-ness to it. Long time ago. Yeah, I'm seeing like a lot of binary stuff, so I'm like, this feels interesting. For X, the PDP-11. I don't know what that is. Here's some examples. This is the quoted text. This string contains a single backslash. You backslashed and then you new lined. A very old computer. Okay. I was like, what is that? 6F in the hex is character X6F. Oh, what was backslash X? They didn't. Oh, okay. Number. Okay. Interesting. 6F in hex is character O. Warning. Escape sequences start with a backslash, not a forward slash. If you use a forward slash by accident, it may still compile, but will not yield the desired result. It's interesting. What's going on? Hello? Ad blocker's not ad blocking. Pause. And then, oh, hang on. And then resume. Okay, it was working, but then, I don't know. That was strange. Where am I? Up? Okay. New line versus end line. We covered this topic in lesson 1.5, Introduction to IOStream, character output, character input, and end line. What's the difference between putting symbols in single and double quotes? Text between single quotes is treated as a character literal, which represents a single character. For example, A represents the character A, plus represents the character for the plus symbol, 5 represents the character 5, not the number 5, and backslash N represents the new line character. Yeah, what? Neighbor trouble, what is going on? What the hell am I hearing? Text between double quotes, hello world, is treated as a C-style string literal, which can contain multiple characters. We discussed strings in lesson 5.2, literals. Best practice. Single characters should usually be single quoted, not double quoted. T, new line, not T or new line. One possible exception occurs when doing output, where it can be preferential to double quote everything for consistency. Okay. What music? I did feel like I was hearing music or something. I was like, huh? Is it like super loud? I don't know. I didn't like hear it like crazy. Avoid multi-character literals. For backwards compatibility reasons, many C++ compilers support multi-character literals, which are character literals that contain multiple characters, like 56. If supported, these have an implementation defined value, meaning it varies depending on the compiler because they are not part of the C++ standard, and their value is not strictly defined. Multi-character literals should be avoided. Damn. Best practice. Avoid multi-character literals. All right. Multi-character literals should be avoided. Best practice. Avoid multi-character literals. Okay. Multi-character literal support often causes problems for new programmers when they forget whether escape sequences use forward slashes or backslashes. Okay. We need to use a forward slash instead of a backslash here. Uh-oh. Whoops. Yeah. The programmer expects this program to print the Programmer expects this program to print the value 3 and a new line, but instead, on the author's machine, it outputs the following: 312, 142. The issue here is that the programmer accidentally used new line multi-character literal consisting of a forward slash and an n character instead of /n, the escape sequence for new line. The program first prints 3, the result of add 1, 2 correctly, but then it prints the value of multi-character literal \n, which on the author's machine had the implementation defined value 12142. Warning, make sure that your new lines are using escape sequence /, not multi-character literal \n. Key insight. Note that if we'd double quoted the output, the program would have printed 3 \n, which is still wrong, but much less confusing. How is it less confusing? Where did 3 come from? Oh, the 3 is still from here. Okay. That is less confusing. Yes. Here's another example. Let's start with the following. The value of x is x. New line. This program outputs exactly as you'd expect. The value of x is 5. But this output isn't nearly exciting enough, so we decide to add an exclamation point before the new line. That's gonna mess things up, I think. Because this needs to be double quoted. Because now that's a word. We expect this to output the following. The value of x is 5. Because exclamation point new line is a multi-character literal, on the author's machine, this actually printed the value of x is 5 and then 8458. This is not only incorrect, it can be hard to debug because you're likely to assume that x has the wrong value. Using double quotes when outputting character literals instead of single quotes makes these kind of issues easier to discover or avoids them entirely. What about the other character types? Okay, we got W character T, character 8T, character 16T, and character 32T. Much like ASCII maps, the integers 0 to 127 to American English characters, other characters encoding standards exist to map integers of varying sizes to characters in other languages. The most well-known mapping outside of ASCII is the Unicode standard. That's probably what I'm thinking of more, actually. I think Unicode is what, with all the emojis, which maps over 144,000 integers to characters in many different languages. Because Unicode contains so many code points, a single Unicode point needs 32 bits to represent a character. Okay. UTF-32, called UTF-32. However, Unicode characters can also be encoded using multiple 16-bit or 8-bit characters, called UTF-16 and UTF-8 respectively. Character 16 and character 32T were added to C++11 to provide explicit support for 16-bit and 32-bit Unicode characters. These character types have the same size as standard. I'm like, uint least 16T and least 32T, respectively, but are not distinct types. Character 8T was added in C++20 to provide support for 8-bit Unicode, UTF-8. It is a distinct type that uses the same representation as unsigned character. You won't need to use character 8T, 16, 32T unless you're planning on making your program Unicode compatible. W character T should be avoided in almost all cases except when interfacing with the Windows API, as it is implementation defined, as its size is implementation defined. Unicode and localization are generally outside the scope of these tutorials, so we won't cover it further. In the meantime, you should only use ASCII characters when working with characters and strings. Using characters from other character sets may cause your characters to display incorrectly. Okay. That was kind of a long one. I think I will do a BRB. Does this one have a quiz? It's a quiz. Oh, this one's kind of long too. But I think this one, we have this one and then the review. Yeah, summary and quiz. Okay. 1 and 2. That shouldn't, right, short program. Okay. Shouldn't be crazy. All right, we will BRB. Yeah. Thank you. I'm back. I had to get the neighbor drama. Figure out what the heck. I don't know.
Chicken.
Got these. I don't know. These new neighbors. I feel like this house near us, like they can't like keep someone there for very long, so we're getting like new personalities like all the time. I don't know what's going on. Is it if it's like too expensive or something? Sorry, I'm all unsettled. Okay. How you doing, Maddie? Maddie girl, how are you? Maddie update. How are you? Oh. All right. Oh, you can't even see her. Just her butt. Oh. Shy girl. Okay. Let's see. All right, we got this, and then we have a review. I don't think we'll BRB. I think we'll finish out chapter 4 and then end stream. Let's try. We could try. 4.12 Introduction to Type Conversion and Static Cast. That's like static assert. That I keep thinking of that one. It just sounds so funny to me. Implicit type conversion. Consider the following program. I still haven't updated my stream deck. I need to consider the following and on my stream deck. Excuse me. Print takes a double parameter. What happens when we pass an int value?
Consider the phone.
What do we... Okay, conversion. I was like, what are we talking about here? In the above example, the print function has a parameter of type double, but the caller is passing in the value of 5, which is of type int. What happens in this case? So we've put a function that's asking for a double. We're calling that function inside of an int main. So we've passed a double into an int. In most cases, C++ will allow us to convert values of one fundamental type to another fundamental type. The process of converting data from one type to another type is called type conversion. Thus, the int argument 5 will be converted to double value 5.0, then copied into parameter x. The print function will print this value, resulting in the following output, 5. A reminder. By default, floating point values whose decimal part, that is really weird, this is a decimal point, whose decimal part is 0 print without the decimal places. Like 5.0 prints as 5. When the compiler does not type conversion on our behalf without us explicitly asking, we call this implicit type conversion. The above example illustrates this. Nowhere do we explicitly tell the compiler to convert integer value 5 to double value 5.0. Rather, the function is expecting a double value, and we pass in an integer argument. Compiler will notice the mismatch and implicitly convert the integer to a double. Here's a similar example where our argument is an int variable instead of an int literal. Gotcha. Like, this isn't int literal. And this is these are the variable. What? Right? Print takes a double parameter. Character output X. Print Y. Wait. Int Y. Okay, print is up here. Print Y. So character output Y. Y is a type of int. This works identically to the above. The value held by int variable y, 5, will be converted to double value 5.0, then copied into parameter x. Type conversion of a value produces a new value. The type conversion process does not modify the value or object supplying the data to be converted. Instead, the conversion process uses that data as input and produces the converted result. Key insight. The type conversion of a value to another type of value behaves much like a call to a function whose return type matches the target type of the conversion. The data to be converted is passed in as an argument, and the converted result is returned in a temporary object to be used by the caller. In the above example, the conversion does not change variable y from type int to double, or the value of y from 5 to 5.0. Instead, the conversion uses the value of y, 5, as input and returns a temporary object of type double with value 5.0. This temporary object is then passed to function print. Excuse me. For advanced readers, some advanced type conversions, those involving constant cast or reinterpret cast, do not return temporary objects, but instead reinterpret the type of an existing value or object. Interesting. Implicit type conversion warnings. Although implicit type conversion is sufficient, Although implicit type conversion is sufficient for most cases where type conversion is needed, there are a few cases where it is not. Consider the following program, which is similar to the example above. Hang on. I gotta hit it.
Hello. Today on Consider the Following, I'd like you to consider the following.
Print now takes an int parameter. Warning, we're passing in a double value. Don't be scared. Well, where is void? It's just makes it a double because there's a decimal.
Wait a minute. Who are you?
In this program, we've changed print to take an int parameter, and the function called to print is now passing in double value 5.5. Similar to the above, the compiler will use implicit type conversion in order to convert double value 5.5 into a value type int, so that it can be passed to function print. Unlike the initial example, when this program is compiled, your compiler will generate some kind of warning about a possible loss of data. Because you have treat warnings as errors turned on, you do, right? Yes. And when you tell me to turn it off, I don't because it's too much trouble. Your compiler will abort the compilation process. Yeah. We want clean code. Tip. You'll need to disable treat warnings as error temporarily if you want to compile this example. I know, it's like you keep doing that. You tell me I need to have it enabled, and then you keep telling me to turn it off. Stop it. Okay. When compiled and run, this program prints the following. 5. And we want it to be 5.5. Oh no. Int void. Is it? Why is it doing that? Excuse me. I'm sorry. I should not be coughing into the mic. I did not take my steroid today. Note that although we passed in value 5.5, the program printed 5. Because integral values can't hold fractions, when double value 5.5 is implicitly converted to an int, fractional component is dropped. And only the integral value is retained. Okay, so it is converting this to an int. I thought it was going to convert the int to a double. We're passing in a double value, so yeah, it's gonna drop it. Okay. Because converting a floating point value to an integral value results in any fractional component being dropped, the compiler will warn us when it does an implicit type conversion from a floating point to an integral value. This happens even if we were to pass in a floating point value with no fractional component like 5.0. No actual loss of value occurs during the conversion to integral value 5 in this specific case, but the compiler may still warn us that the conversion is unsafe. Because they don't know what numbers you're putting in there. Key insight. Some type conversions, such as character to int, always preserve the value being converted, whereas others, such as double to int, may result in the value being changed during conversion. Unsafe implicit conversions will typically either generate a compiler warning, or in the case of brace initialization, an error. This is one of the primary reasons brace initialization is the preferred initialization form. Brace initialization will ensure that we don't try to initialize a variable with an initializer with an initializer that will lose value when it is implicitly type converted. How you doing? It's like farting. Yes. Every Tuesday, we're hacking the mainframe. I really didn't absorb any of that because I was so stuck on how many times I had to say initialization. Initialize and initializer. I've never seen that. Hack the planet? Oh my god. Hackers. Oh, okay. No. I have heard of that. Okay. I was like, I have not heard of that movie. I've not seen it though. Yeah. Like I'm getting like images in my head. Like, yeah. I'm seeing like leather gloves. Okay. Give me a second. It's like a key insight and I'm not getting it. Like, I'm just like, did I not get what brace initialization is? Oh, these are braces. Brace initialization. Okay, no. I know what we're talking about now. We're back on track. Zero cool. Yeah, zero cool. That's crazy. Okay. Int to double is safe. Double to int is not safe. Okay. We have learned this. Related content. Implicit type conversion is a meaty topic. We dig into this topic in more depth in future lessons, starting with lesson 10.1, implicit type conversion. An introduction to explicit type conversion via the static cast operator. I know, I'm like, meaty topic. I wasn't expecting to see the word meat in a C++ lesson. Back to our most recent print example. What if we intentionally wanted to pass a double value to a function taking an integer, knowing that the converted value would drop any fractional component? Turning off treat warnings as errors just to make our program compile is a bad idea, because then we'll have warnings every time we compile, which we will quickly learn to ignore, and we risk overlooking warnings about more serious issues. C++ supports a second method of type conversion called explicit type conversion. Explicit type conversion allows us, the programmer, to explicitly tell the compiler to convert a value from one type to another, and that we take full responsibility for the result of that conversion. If such a conversion results in the loss of value, the compiler will not warn us. To perform an explicit type conversion, in most cases we'll use the static cast operator. Syntax for the static cast looks a little funny. It is new type expression. It's so explicit. Static cast takes the value of an expression as input and returns it returns that value converted into the type specified by new type. Int, bool, character, double. Just remembered this freaking store. Just
Get you for this!
chicken. I was at Walmart. I'm gonna tell a story. I was at Walmart today. I'm at the self-checkout. I bought a chicken. I put the chicken in the cart, and then I got frustrated because I got like some chicken goo on my hand, and I'm like, oh, this sucks. But I'm like, whatever, I just gotta keep going. So then I grab, I know, it's just stress. Then I scan the next thing, and it like stops me, and it's like associates coming over, and I'm like, oh, okay, like why, like what did I do, or like what does it need, like do I need an ID for my biscuits, like what's going on? So she puts her code in or whatever, and then it like this, I was like so frustrated, I was so upset. Comes up with this screen that says was something misscanned, and then it shows like a little video snippet of just me putting the chicken in the cart, and I'm like, what the hell, like what like what's going on? And then the lady goes, ma'am, and then she like scrolls up and she's like, the last thing you scanned? I'm like, the biscuits that are still sitting right here? And she's like, okay. And then she just walks away. And I was just like, was I just like accused of stealing just now? Like, what is going on? Like, it was just so, like, it started with the chicken goo on my hand. And it was just like, there was like no like, oh, this thing's doing whatever, like, or sorry, or like, you're good. She was just like, oh, and then left. But it was just like, what's happening? Like, I felt like Big Brother, like, it was like tracking my movements. Like that's what I was like, what? Like, what are you doing? Like I still feel like heaved out. Literally. That's why I was like, the thing that I think it wasn't fully the computer. It was that this lady went like, all right, now I'm a police officer. Like, I'm gonna get you. And it's like, really? Like, if it were me, if I worked at Walmart, I would have just been like, what the fuck ever. Like, even if I saw someone stealing. Sorry. I'm just like, that's me, obviously. If you actually see someone stealing, obviously you can be like, oh, well, like, let me get someone or whatever. But the fact she was like, ma'am, and I was like, literally, like, what? Like, I just felt like very shook up after, because I'm like, okay, this computer's tracking me. The lady doesn't even have my back. That like, wow, this computer's tracking me. She's like, get her computer. And I'm like, what? It was just a lot. Okay. Okay. I know. I was like, because that was the first point of like kind of dystopian, like it was like COVID time and stuff, but like it was Target. I was like the first one that had like the camera on you, and it's like make you feel like a criminal for just like trying to patronize your business. Like, I'm sorry. But like shit like that, like it makes me not want to go. Like, I don't want to go now. Like, I don't know. I'm just like, that's why world's too scary right now. That was literally the issue. I was like, what? And it was like, do you want to print the receipt or have it texted to you? I'm like, I'm gonna print this damn receipt. Like, they're gonna tackle me. I'm gonna be arrested with chicken goo on my hands. Okay. Key insight. Whenever you see C++ syntax, excluding the preprocessor, that makes use of angled brackets, thing between the angled brackets will most likely be a type. This is typically how C++ deals with code that need a parameterized type. Let's update our prior program using Staticast. Literally, I was like, they're tracking all my purchases. It was a few years ago. I had realized that like Target, I just had like, cause you have like your phone number for like, you know, rewards or whatever. Probably had that for years, and then realized a few years ago that like my purchases in store were being logged like into my online account, and I'm like, oh fuck, like Jesus. I don't know, just I don't know. It's like I love technology so much, and then I also have the fantasy of just like I need to go off grid. I need to just live in the woods with my own internal network. Because you're up to something. Literally. Literally. That I feel like it's just, I'm so paranoid, like distrusting right now. I'm like on like, you know, consumer rights side of shit. So like I'm just seeing how just horrible things are. I think it's from existing in a world where things weren't so horrible. So it's like, no, this is not right. Yeah, it's like, this isn't how it used to be. Or at least was less obvious. Yeah. I don't know. What's that like? It's like we started like bartering with our neighbor. I won't say what, but it's like that feels so much better right now with the state of things. It's like, hey, like I'm helping you, you're helping me. I don't know. Okay, static cast gets put. Where did that get changed? Wait. Okay. Okay, we're telling it to print 5.5 and it's upset. I literally, I don't understand how that hasn't made a comeback yet. That is still one of my favorite. Actually, I'm like, let me, because this is an idea for a stream, but I just need to get the part. I have my Game Boy Advance. This is still, we need more see-through pink tech, but it's one of my favorite consoles. The screen is extremely dim, and so I've already extracted it. A Game Boy SP screen, and we are going to put them together on stream, and that's gonna be scary, but I just need to get the parts still. There's like some ribbon I need or something. I don't remember. Yeah, so like custom stuff, there are the people, you know, that are still obsessed with it, but it's more just like in like actually like Nintendo. Like Nintendo, what are you doing? Like, why are there not see-through Joy-Cons? What are you doing? I'm sure it would look incredible. Right? Just flap it. Oh, Xbox, honestly, okay, I'm a PlayStation girly, but there's just been such a strong frustration with Sony that like Xbox's controller game, like as far as the designs, are so much better. I'm just like, let's get it together. I don't know, like Xbox knows like the shades of pink that are good. The stuff that people want, like actually. So like sometimes PlayStation will release something that's like, I don't know. Like, I don't mean to judge, but it's like it was like orange with, it was PS4 controller, but like orange with navy blue. It just looks so ugly. I was just like, why, who chose this color combo? Why are they doing this to me? I don't know. I already read this. Okay, we were going up to see the change. We had the double in there, and now we're saying, okay, but this is a static cast double. So I get that it's gonna be bad, but just we're cool with it. Because we're now explicitly requesting that double value 5.5 be converted to an int value, the compiler will not generate a warning about a possible loss of data upon compilation, meaning that we can leave treat warnings as errors enabled. Related content. C++ supports other types of casts. We talk about the different types of casts in future lesson 10.6, explicit type conversion, casting, and static cast. Using static cast to convert character to int. In the lesson on characters 4.11 characters, we saw that printing a character value, standard character output, results in the value being printed as a character. So we put the ASCII character in, or ASCII code in for A, so it'll print A. Okay. Like such a gap. Prints A. If we want to print the integral value instead of the character, we can do this by using static cast to cast the value from character to int. Cypher. That's a good name. Oh my goodness, the pink. God damn it. I mean, they work. Okay. I'm like, they work with Windows, but my biggest issue with Xbox controllers is like my hands are too small. They're just like, it feels so large, or like I can't get to exactly where I want it. What is the D-pad? I was like, what am I looking at? The D-pad looks so cool. I like I think all of them. I love the like clear. And the pink buttons with the green, oh my gosh. Okay. Question. Answer. Got a question. Oh, I was like, what? This is from the last stream where it was having us, which also, is this the one that we wrote that we loved and then I think I replaced it? Yeah, it was like enter a number 0 through 9. It was like, I guess we were doing like if else's, I guess, else ifs. The Bailey PSW primality test. If you need this for real. I don't need it for real, but I need to write that down. A primality test sounds like something I need. Like, I assume there's like maybe like a line of code or lines, simple loops. Ooh. Okay, yeah. I don't need it. We are just learning like if statements. So that's a little above our head right now, but honestly, when it was asking me to do it, I was like, there has to be a better way than just like if this just list all the prime numbers. I was like, that doesn't sound efficient. Let's see. Oh wait, sorry, I just read the design lab. So you can like pick like what buttons and faceplates you want stuff. Dang. I bet. It's like, there's so many numbers. Like, what the hell? Um, $97, character output A. A has a value of 97. Huh? Because this is the value. Output character A has value. Oh, because we static casted this. Okay. Okay. It's worth noting that the argument to static cast evaluates as an expression. When we pass in a variable, that variable is evaluated to produce its value, and that value is then converted to the new type. The variable itself is not affected by casting its value to a new type. In the above case, variable ch is still a character and still holds the same value even after we've cast its value to an int. Sign conversions using static cast. Signed integral values can be converted to unsigned integral values and vice versa using a static cast. The value being converted can be represented in the destination type. The converted value will remain unchanged, only the type will change. For example, convert the value of u1 to signed int. Signed 1, static cast. Oh, this is getting a little in the weeds for me. Okay, u1, which is 5. Output s1, which is 5. Prints 5. S2, 5. Convert value of s2 to an unsigned int. Prints 5. 5 and 5. Since the value of 5 is in the range of both a signed int and an unsigned int, the value of 5 can be converted to either type without issue. The value being converted cannot be represented in the destination type. Wait, if the value being converted cannot be represented in the destination type, if the destination type is unsigned, the value will be modulo wrapped. What? We cover modulo wrapping in lesson 4.5. Okay, we're coming up. Wait, what? What lesson are we on right now? We already did that. Why don't I recognize that word? Unsigned integers and why to avoid them. We did do that one. Maybe I just need an example of what that is and I'll be like, oh, right. Value modulo wrapped. All right. Sometimes called. That's probably why I was like, what? It's a wraparound. Okay. That was the sound command I want to add is wraparound. Okay. Now I get it. Okay. So if the destination type is unsigned, the value will do a wraparound. If the destination type is signed, the value is implementation defined prior to C++ 20 and will be wrapping around as of C++ 20. Here's an example of converting two values that are not representable in the destination type, assuming 32-bit integers. Unsigned integer s, we're static casting s, so that'll be the ASCII. But then also -1 is s. So we're static casting -1, not s. So, right? And then if we cast the actual ASCII, it should give us -1. As of C++20, this produces the result. Right, okay. It said it would. Signed int value -1 cannot be represented as an unsigned int. The result modulo wraps to unsigned int value, that number. Unsigned int value cannot be represented as a signed int. Prior to C++20, the result is implementation defined, but will probably be -1 as of -1. As of C++20, the result will be modulo wrap to -1. Fuck. I'm like, why make me like say this? Sorry, wait, did I read? I didn't read this. Warning. Warning. Converting an unsigned integral value to a signed integral value will result in implementation defined behavior prior to C++20. The value being converted cannot be represented in the signed type. Standard int 8t, standard int 8. Thank you. With a J? Modulo? Like that? I don't know. As noted in lesson 4.6, fixed width integers and size t, most compilers define and treat standard int 8t and standard uint 8t and the corresponding fast and least fixed width types identically to types signed character and unsigned character, respectively. Now that we've covered what characters are, we can demonstrate where this can be problematic. Modular. That helps me a lot, actually. Modular. That does have like a J sound for D. I'm like, how are we getting J from D? Modulo. Modular. Module. Modulo. So interesting. Who made that word? Module. I was literally just like, whoa. Yeah, feels like it. It's like the root of everything. English language. What is this? Whole. Okay, hang on. Modulus. Small measure. Oh. Whoa. That actually, honestly, I do need to like study Latin a little bit. Just, I know I get like some root words and things, but I could understand so much if I really got the roots of stuff. Okay. Didn't know how to explain the issue I was having. We're good though. So like, this might be broken. Oh no. Let's show this. My cart, I don't know. I get to show it. The like center part there came off and was like stuck in the pen. Okay. Ensign Michael's the math one. Actually, also Fayori too. Math ones. We're kind of on a wing and a prayer here. Math and I sometimes can get along if we understand each other, if we have rules. But, you know, a struggle.
Baby girl. You're itchy girl. Hello.
There's no question. It's like they're not a math question. It's just maths in general. But like there's a whole field of mathematics based around modular arithmetic, and it's like holy shit. Not heard of that. I'm not in the math world like that. That's so interesting. Okay, give me a second. Okay. That's like encrypting things, right? Like one of my favorite things is learning about the like Cloudflare encryption with the lava lamps. I thought that's like so interesting. Because I had heard that like, you know, true randomization is like something that hasn't been like achieved with computers, and I thought that was just like so creative. I don't know what an entropy source is. I saw cryptography and I was like, cartography? Whoa. What's just left? Hang on, wait, I don't want to lose my spot. Wait, we're at the warning. Warning. Oh, okay. Oh, we're almost done. Okay. Straighten up. All right. Yeah, I had pursued computer engineering in my early 20s, and I gave up pretty quick. I was like, I hate this. We gotta learn this though, because we gotta make video games. And honestly, I feel I know that there is a lot of math when it comes to programming, but there is also something a little bit like it's called a language. Like it literally, I do feel like I'm learning a language right now. Like the language parts of my mind are online, kind of a thing. Cartography is fun too. I was also just hearing about what was it? Africa is like pushing to use like a more accurate world map. The stellar cartographist, Ensign Michael. Yeah, like Japanese is no joke. Like I try learning like just speaking it and things, but then like actually trying to learn like the kanji. I don't know. You have to be like really committed or raised and around it and like around it all the time, Is the brain is pliable, but it also it likes its habits. It's the ways it knows how to do stuff. Literally, yeah. It's like it's like even just trying to explain like, oh, like certain sounds like together will make like a completely different looking kanji. Like I have no idea how to learn that unless it's like everything I'm learning. There's too many things to learn in the world. All right. That's true. Right? It's like you just need like the basic stuff. As noted in 4.6, fixed width integers and size t, most compilers define and treat standard int 8t and standard uint 8t and the corresponding fast and least fixed width types identically to types signed character and unsigned character respectively. Now that we've covered what characters are, we can demonstrate where this can be problematic. Initialize my int with value 65. You're probably expecting this to print 65, aren't you? Well, I guess because we're doing int 8 that it wouldn't. Yeah, because int 8 describes itself as an int, you might be tricked into believing that the above program will print an integral value 65. However, on most systems, this program will print a instead, treating my int as a signed character. However, this is not guaranteed. On some systems, it may actually print 65. If you want to ensure that a standard int 8t or standard uint 8t object is treated as an integer, you can convert the value to an integer using static cast. It will always print 65. We've static casted that. I really want you to say this, please. Remembering the kanji. Like those are like the ones to remember kind of a thing. In cases where int 8t is treated as a character, input from the console can also cause problems. Oh lordy. Character output. Enter a number between 0 and 127. Character input, my int. You entered. We static casted my int. A sample run of this program. Enter a number between 0 and 127. 35. You entered 51. Here's what's happening. When standard int 8t is treated as a character, the input routines interpret our input as a sequence of characters, not as integer. So when we enter 35, we're actually entering two characters, 3 and 5. Because a character object can only hold one character, the 3 is extracted, the 5 is left in the input stream for possible extraction later. Because the character 3 has ASCII code point 51. The value 51 is stored in my int, which we then print later as an int. Okay. I needed to know that this was treated as a character. So it'll only take one character. Oh, nice. My sister actually, she took Japanese in college, and I was just going through my closet the other day. I have this box of like keepsakes, like memories and stuff, and there was a whole bunch of like, oh, it's like the Japanese flashcards she gave me. It was like all the workbooks and stuff that she had from the class she gave to me I was supposed to actually practice, but I did not do that. But they're cute and they're cool. In contrast, the other fixed width types will always print an input as integral values. Okay. Quiz time. Quiz time. We got this. Question 1. Write a short program where the user is asked to enter a single character, print the value of the character and its ASCII code using static cast. Oof. Program's output should match the following. Enter a single character, A. You entered A, which has the ASCII code. Okay. That's pretty cute. I think I could do that. Honestly, my plan is to just go through. I'm a little bit also making content. I feel that this website is genuinely good, and I think people do really enjoy like sitting and hearing like audiobook basically of the website. I guess mixed in with my stoned ramblings, but they honestly make us code still here. Like we're still doing stuff and it's pretty early on. So I am curious like what kind of programs like these quiz times are going to be asking us to write. Yeah, that is my favorite part. Like it's not just me sitting here getting frustrated. There's been multiple times where we've been like, why isn't this working? And someone's like lurking and they'll be like, this needs to be fixed. I'm like, oh my god, thank you. Like, it's honestly so helpful. And then it's like, why did that work? And then they're able to like speak to me and explain like this happened because of this. And it's like, oh yeah, I've been like going back and forth like, do I go back to school? Like, and I'm still a little bit like, do I go back to school? Because I like structure, but I'm like, if I can actually stay streaming and give myself that structure, we could do it for free. We could learn for free. Yeah. Honestly, it's just, I feel with I don't know, I get nervous thinking about like the later chapters. I feel like I keep getting a lot of warnings about C++. But I don't know. My boss, he codes in PHP, which I think also gets a lot of flack. And so I guess I'm just kind of used to like, no, like you pick the language that's best for you. It just, I don't know. Yeah, I know. He loves it though. Like it is his fave. He does like all kinds, but like PHP is his fave. All right, we can do this. Wait, modify the program you wrote to use implicit type conversion instead of static cast. That's gonna be scary. All right, let's get rid of this. Pew. Personal homepage. All right. Single character, print the value of the character and its ASCII code. Okay, we're gonna move up. Hang on. Yeah, it's like it more website based, right? Like, he does more like web applications and things, so that fits, but all right, I think I want this one as my template, maybe. Main double int, yeah. Not exactly, but like, do we want print though? Hang on. We also want this one as well, but not exactly. All right, I'm just gonna start getting some lines together and we'll move it around. We'll figure it out. Yeah, so like definitely that. Oh, I need to use home row keys, son of a bitch. And then true. Enter a single character. I want new line as well, I think. Or no, that's not a new line. Sorry, I get a little I want to like 100% the quiz, so I like get very like almost character specific, that it'll be exactly the code that they have in the solution. We don't always get 100%. So enter a single character. Probably space though. Yes. And then I think we want a new line though. No. No, let's leave it right now. I know, that's what, like, the last stream, to check the, I don't think the one we had there was the one we wrote, but, maybe it was, but I loved the code that I wrote, and then the solution, it was, like, actually a couple lines more, so I'm like, I don't know what the CPU thought was more efficient, I don't know. I know, it's like, I try to just make sure I'm like really getting like what they're trying to be teaching me. We need static cast as well. Okay. And then we need to initialize. Oh, like it's unintuitive like to read, but the CPU will enjoy doing it more. I see that. I'm trying to think about what I want to call it. I guess CH is what they've been doing, character. Right, that too, compiling. All right, we'll do character input. I'm not using home row keys, crap. CH? We haven't initialized CH anywhere. Give me a second. Okay, let me put the output in as well. Just so she's there. Crap. Keep your hands where I can see them. Okay. Okay. You entered. Fuck. CH. No, that feels wrong. Wait. We wanted to static cast the ASCII. So do we need to brace initialize? Is that the word? Thank you for following. I want to get out of this because I don't think I'm dealing with this right now. Okay, no, don't want to be here either. Yeah, okay, we're braced here. Okay, it is just CH. Character. That looks cute. I like that. Character CH. Feels better. CH. And then we need to static cast CH as well. I don't remember what the wording was for ASCII. I just want to get the static cast syntax right. Static assert. I have to put int so it'll do the ASCII, right? That feels good. I don't know. You entered a... Ooh. Which has ASCII code of static assert character. Enter a single character. Character input. Is this okay here? I think we can... This is fine. I think this is okay. Gotta return. No, wait, this is upset. Why are you upset? Add at the end of previous token. Why? You're confused. Too many, Is it these guys that are confusing things? No, it's still upset. It does not like CH. We can do... Hang on. Do I need to put the braces, I guess? It feels strange. Character CH. No, let me see what happens. No, it still doesn't like it. Give me a moment. It was kind of specifying that initialized brackets are kind of separate. Yeah, I think so as well. I guess I'm just... You're saying like these ones. I'm more... Oh. Wait. What are you upset about? No, I'm still upset about this line. Just don't know why that went away. It's upset with this one. Yeah, I would like a hint, because, is it the... I'm like, where did I go wrong? Oh. No. What? Oh, no, wait, I don't need to look at chat. I already know. I remember. We got it. Okay, we got it. I was like, something is wrong. Okay. Which means that I can add this back. Okay. Now we could check it. Thank you so much. Ooh, ugly code stuff as well. Yeah. Alright, we got A. I think we did it. I feel like we did it. That is, hang on. The result they were looking for was Yeah, I feel like we win as long as the result is exactly what they asked for. It's just really fun if the code that we wrote is the same, but I don't think it's really possible once we get more in the weeds. Character A. Beautiful. I want to do it again. C. 99. Oh, this is fun. M. 109. That's so fun. All right, now we're modifying it to use implicit type conversion instead of static casts. How many different ways can you think to do this? Thank you. You should favor explicit conversions over implicit conversions. So don't actually do this in real programs. This is just to test your understanding of where implicit conversions can occur. Okay. They just read text. That's what I'm like. It's got to be like their whole world, you know, like they look at it day in, day out. Needs to be explicit. Wait, did we even look? We didn't even look at the solution. I was just like, we did it. Because I'm realizing, I think this int here, maybe. Let's see. No. They did C, not character. How are you going to throw that curveball at me like that? You know, it really does look better without the brackets. But I think I maybe like it, just like having the brackets there, my brain knows initialization is happening here. You know? I guess maybe I should just know that without it. Okay, static cast. So we did fine. We didn't have a period. Stupid. Okay. Well, what will make it explicit? I know it's like putting stuff in the brackets, right? Like this is explicit or something, right? I feel like that is the answer. Like we want to do 97. Well, this won't work because then character input. Hang on. What are they saying? To use implicit type conversion. We don't want to do this then. Type conversion. Explicitly converting the character to an int with static cast int. Compiler can implicitly convert types sometimes. That's kind of what I'm like, I feel like I'm already being explicit right now, and that this also is explicit with the int. That's what I thought was That's what I was picking up from the lesson. Okay. That's why I'm like, how do I make this more explicit? How can I be more clear? Well, so it's like, how many different ways can you think to do this? So maybe... have this be an int to start? That won't work. Wait. Switch. They want me to make it implicit? Oh, I'm not fucking paying attention. Okay. So they want me to make it not explicit. Okay. I'm like, I don't understand how I could do this more. Okay, okay. I think we could just static cast. Okay. We got it now. We're on it now. We're moving. So it won't like that, right? It'll be okay with that. Just a regular old... Yeah, no, it's not happy. Expected a type specifier. Well, okay, you can't just static cast on your own. You can't just be doing that. It needs to be implicit. Right. Okay, at the very beginning, they showed implicit. Double. And then it's an int. So maybe we just... Okay. So we want this character to be an int. I'm thinking. I feel like I'm like messing it up worse. All right. I'll take a hint. So I do feel like I'm messing something up. I think we don't need static cast, because that is making it explicit. That's what I'm thinking. We just do the int over here. I'm just like, because these have to be different. So like this one has to be an int and this one needs to not be character. So that will be a character. And then character int, and then print character int instead of character. So there will be two, character and character int. Okay. That feels like the easiest thing in my head. And then I'm just gonna be upset for a second. We want how do we convert it? Hang on. I guess int but we need we need to take this. Hang on. We get it from character input. Okay. It can't be before it. It's like, I guess what I'm wondering is like, how do I take CH and tell it? Oh, wait. Duh. Okay. Hang on. It doesn't look, oh, maybe it is fine actually, but for some reason this isn't blue like it should be, but maybe it's fine. That don't look great. Ah, dang it. Sterile formed. Ban, get out of here. 9711786. Just like, why isn't it not getting it? Okay, we've initialized this with A, and that should be implicitly switching. Oh, but it's probably upset though. No? I don't think it should be. Unsigned in. I was, I guess, trying to avoid it. See if it's like static cast. Local variable. I click it, it connects. CH. It's fine. Oh. Okay. Equals? Like instead of initializing, we're literally like... This feels weird. I don't know if this is C++. Oh, yeah. Maybe happy? Eh? No, it's still upset. I think it's probably about the same. I feel like it's whatever is being passed from characters where the break is happening. Void print, but man. Character just look at this. I'm a little bit at that point. I'm like, I gotta end stream. I still have the review to read. I don't know. Especially if they're saying there's like multiple ways to do it. I feel like probably doing that other like function is another way, but that feels messy. Oof. There are a few ways to do this. First, we can create an int variable and initialize it with our character value. So do the implicit conversion on initialization. Enter single character. Did that. ASCII. What? Oh, that's like the, okay. That's like our character int. Character. This should have worked. Right? Am I wrong? Is this what we had? Isn't that what we had? Like, hello? Did I do something wrong? What? Character. Character. I think the only thing I changed was just the brackets, but like, hello? C? Oh, just so it's a little more, I can compare a little easier, because I'm just like, what the hell? You entered character, which has ASCII code. It should be 97. A. Does 97, and then it does. Is it doing? $11,786. What is it adding to the end of that? Yeah, I'm like, we are getting 97. It is giving it, but for some reason it's throwing more shit on top. I don't know. Let's just say we got it, I guess. Thank you, Justice. We got it. We didn't get it, and we got it. Alternatively, we can use a function. Yeah, it was like maybe like another function, but that just feels weird. Use a function to return the character value as an int. This will do the implicit conversion at the point of return. We can also use a function and have the implicit conversion happen at the point where the argument is copied into the function parameter. Enter a single character. Hang on. Get int, return C. So we're at a C. Like, it's already an int and then it's making it a character at a point here where the argument is copied into the function parameter. Yeah. So it does that switch here. Okay. I don't know. Right, how long is this? Is there a quiz? Oh God. Okay. I did this last time. There's just so many questions here. Hang on. Oh wait. Oh, is there just one question? No, these are a bunch of different questions. They say one, but it's a bunch. 2, 3. Okay. Okay. Lambda. That's a math thing, isn't it? If int f, return f, character. F. So yeah, I did this last time where I was like, oh, you know what? We'll save the summary for next stream as a refresher before we go on to the next chapter, because it is getting kind of late. But the last time I did that, I did not then do another lesson for a year, and so then we just kind of skipped that summary. It was about debugging though. It's fine. Me too. I'm gonna go to sleep. We're gonna end stream. We're gonna save. We will actually be back Tuesday. We will. It's not gonna be a year that we continue the lesson. Let's figure out who we're rating. Oh, I don't want to do the typing test either. Yeah, thank you for hanging out. All right. Oh, Ben, thank you for the follow. I think we got a pretty easy raid tonight. We got that is so interesting. A lot of Legends of Zelda tonight. Good time to not deal with it today. Good night. Spider, you figure out where you're going, and I'm gonna go to bed. Okay, yeah, we're gonna raid the Nidster. Here's the red message. And then, oh, crap. Doing this all wrong. Okay. We'll be back tomorrow. I'm pretty sure we might do more easy delivery code. It might be something else. I don't know. But it's gonna be Wednesday, so it's gonna be chill. So make sure to copy the raid message, because I always forget to do it. I put it in the chat and then I don't copy it. Let's go say hey, and I'll see you guys later. Bye.